Hey guys, welcome to the spring final review video. I'm going to work through some problems that are very similar to the ones that you have, just maybe some different problems than any of you have, but same concepts. So I'm going to talk a lot today, trying to remind you of the things that are required to answer each one of these particular types of problems. So let's dive right in. Number one, the directions say the polygons in each pair are similar. Find the missing side length. Okay, so when I look at number one, I see this is the side they want me to find. I'm going to label it X and then solve for X. The thing you have to remember here is that when polygons are similar, their sides are proportional. Okay, that's something we talked about, which means they all have a common ratio. So what I can do is I look at a pair of sides that I was given. Okay, a corresponding side, for instance, the bottom. And I set up a ratio, 32 to 40. Okay, and that ratio should be the same throughout the whole polygon for each corresponding side. So I know that ratio should equal the exact same ratio as the side I'm looking for. Okay, I just have to be consistent. Since I went 32 to 40, I'm going to go 24 to X. Okay. The way we solve a proportion, now I could reduce the fraction, but I'll worry about that at the end. The way we solve a proportion is we cross multiply. So I do 32 times x, which would be 32x, and that equals the cross multiplication here of 40 times 24. So 40 times 24 is 960, and then I solve. So to solve, I divide by 32 on both sides. Basic Algebra 1, and x equals 30. Alright, so number two, same deal again. I'm looking for this side. I'm going to call it x, call it y, call it your favorite variable. I'm going to look at a side they gave me, so I'm going to use the top here, 18 to 6. And I know that should equal the same proportion here of 12 to x. Alright, so I cross multiply. 18x will equal 12 times 6, which is 72. And then I divide by 18 on both sides. I divide by 18. X is 4. Okay? So the next problem still work kind of with that idea of similarity. State if the triangles in each pair are similar. So now I have to tell if they are similar or not. If so, state how you know and complete the similarity statement. Okay, so just remember to be similar. The sides need to be proportional. And also, I didn't talk about it above, but the angles should be congruent. So all the angles should be the same as the corresponding angles in the other polygon. And all the sides should have the same ratio, the same proportion. Okay? So one way I can prove is based on the info they give me. So first off, just kind of talking about how to eliminate answer choices. They said first, state if they are similar, state how you know. Okay, so I'm going to look at what I was given. What I was given in one is 3 sides, and then the other one I was given 3 sides. So the only info I have is literally side, side, side. They didn't give me anything about angles. So I wouldn't be choosing answer choices like A and B. A says by angle, angle. So that would be 2 angles are congruent. But they didn't tell me anything about the angles. Answer choice B, side, angle, side. That would be if 2 sides were proportional and 1 angle was the same. They didn't tell me anything about the angle. So I already know that either the triangles aren't similar or they are by side, side, side. Now I need a check. Okay, the way I check is I make sure all those proportions are the same. Now, I want to be consistent, so I'm going to cheat here and look at the answer choice since I know it's got to be this one. And I want to be consistent. So if I look at DE, which DE is 130, I need to compare that to TU. If you remember, these should go in the same order with its corresponding side. So if I'm looking at DE, that needs to correspond to TU. So that would be the 50. So DE 130 to 50. Now to be similar, that has to have the same proportion as all the other sides. So EF EF should be similar to UV, which would be 169 to 65. And then last, FD, which is the 182, should be similar to VT, which is 70. Alright, so I need to make sure, quick easy way, I can just go on my calculator and check all three of those proportions. So I'm going to do 130 divided by 50, 169 divided by 65, and 182 divided by 70. And as I work, notice all three of those came out to be 13 over 5. So they are similar by side. If they weren't all the same ratio, then I would have circled not similar. Okay, so on number 4, again, look at what they gave me. They gave me a side, the angle between, another side. So they gave me two sides and the angle between. So I should be looking for side, angle, side. Okay, which is what they all are. So the only difference here is literally this statement. So remember, the statements have to correspond. So what I would start checking is first, they already told me the angle is congruent. I know that. So I need to check, are the sides proportional? So make sure you're comparing the right side. So first, CD, in the first answer choice, I need to compare to QR. So CD is 40, but QR was not given to me. So I can't choose an answer based off information I don't have. So I know it can't be that one. So the next, let me see, if I compare CD to PQ. CD is 40, PQ is 16. So 40 to 16. Then let me check DE. Well, DE wasn't given to me. So what about EC? EC needs to compare to RP, the ones that are in the same position. So 71 to 28. I check, are those equal? So 40 divided by 16. Is that the same as 71 divided by 28? No, they're not the same. So it can't be that one. So right now they're not similar unless this last one checks out. So by side, angle, side, the CD, which is 40, compare to RQ. Well, they didn't give me RQ. So again, I can't do it off information I don't have. And so the only one I was able to check was this one, and I know that's proportions were not the same, so it's not similar. Okay? So let's go look at number 5. Remember, similarity, sides got to be proportional, angles should all be the same. So 5 and 6, this comes down to the easy peasy stuff. Find the missing side of each triangle. Alright, round your answer to the nearest tenth if necessary. So on these, if you're given two sides of a right triangle and asked to find the third, we're going to use Pythagorean theorem. Okay, Pythagorean theorem says a squared plus b squared equals c squared. Remember, you label the legs A and B, and you label the hypotenuse C. The hypotenuse is across from the right angle. So it's going to be really important, even on number 6. That one needs to be labeled C, and then it doesn't matter which one you label A and B, just as long as it's not the hypotenuse. Okay? So then I set it up. A squared plus b squared, so 12.3 squared plus x squared should equal c squared, which is 13.1. Alright, I'm going to go ahead and calculate those. 12.3 squared, 151.29, and 13.1 squared, 171.61. Okay, now I do my algebra. To solve for x, I need to subtract the 151.29. So x squared will equal 20.32. And then remember, that's x squared. Sometimes that's an answer choice to see if you stop there. But to get x, I need to get rid of the square by taking the square root. So I take the square root of that answer 20.32. And I get 4.5. Okay, so I'm going to go look at this again. A squared plus b squared equals c squared. X squared plus 7.2 squared equals 10 squared. I'm going to show my work a little different here. No matter what this number comes out to be, I end up subtracting it over here. So it's going to be 10 squared minus 7.2 squared. And that's going to save me some calculator work. If I just type it in like that, it's 48.16. And then again, that's x squared, though I need to take the square root to get to my answer. So I take the square root of that, and I get 6.9. Okay. Now, moving on to the next one. If I go too fast, guys, pause the video. That's why it's a video. Just pause it, rewind, go at your pace. Listen to what I said 2 or 3 times. Okay? Now, as we get to these problems, I want to remind you guys, we're going to use the calculator to find the value of the trig function. When you work with trig functions, you need to make sure that your calculator is in degree mode. So up here in the upper right corner, you need to make sure that says degree, not radians. Okay, if it's rad, you need to change it. The way you do that, you click right there next to the battery. You'll see the little setting symbol. Click that, go to document settings, and change your angle to degree. Alright? That would actually be the first thing I do when I get my test, when I get my calculator on the final, or even on the final review. Everything else, it's okay if your calculator is in degree mode, so you might as well just go ahead and change it in the very beginning, okay? And work the whole time in degree mode. That way when you get to the trig problems, you don't mess up. Alright? So on this one, if I want to find tangent of 47, remember the trig button's right here next to the 7. I'm going to push that. I'm going to go to tangent. Type in my angle. Again, it's in degrees. That's why I'm in degree mode. Boom. Easy. So easy we shouldn't even put it on the test. Okay? Now we get to actually understanding what trig is. Problems 8 and 9. Find missing side. So if you're ever given an angle and one side, you can find the missing side of a right triangle. So kind of like Pythagorean. Pythagorean works if you know 2 sides, but in this problem I don't know 2 sides. Alright, I just know an angle and a side. Well, that's where we use trig. So remember, you look at the angle they're dealing with, which is 30 degrees. You're going to label your triangle opposite, hypotenuse, and adjacent. So obviously I know the hypotenuse across from the right angle. Across from the 30. Across from is what we call opposite. And the side next to it, that's not the hypotenuse, what we call adjacent. Alright? And then we use our SOHCAHTOA. Or if you have one of those little sayings to help you memorize it. My kids, you know what I'm talking about. This helps you decide what trig function to use. Okay, do I use sine? Do I use cosine? Or do I use tangent? Alright? Well, it depends on what you have, which in this case is the 11 and the x, which is opposite and adjacent. So the one that deals with opposite and adjacent is tangent. So I'm going to start to write my equation. Alright, the setup always looks like this. Except you have to decide, do I use sine, cosine, or tangent based on what I have. That's why we label first. So I use tangent. What goes in the parentheses is always the angle, which in this case is 30. And then here, this tells you how to set it up. Opposite over adjacent. So I'm going to do 11 over x. Alright, once you have your equation set up, you just got to remember how to solve them. If x is ever in the bottom, the way we get out of the bottom is to multiply by x on both sides. So I have x times tangent of 30 equals 11. And then now I need to undo the multiplication of tangent 30 using division. And x is going to equal 11 divided by tangent of 30. So now it's calculator time. I'm going to plug that bad boy in. Boom, 19.05 rounds to 19.1. Okay, let's look at the next one. Number 9, same deal. Here's my angle. This side is the hypotenuse. This is the opposite. This is adjacent. So what they gave me this time is opposite and hypotenuse. So I'm going to use sine. So I start. Again, the setup always looks the same here. What goes next to this is the angle, 56. That's opposite over hypotenuse, 16 over x. And then I solve. Okay, it's going to be the same solving step. So if you notice the pattern here, when you have x in the bottom, basically the x and the trig function are going to switch places. So this is going to be x will equal 16 divided by sine of 56. Divided by sine 56. 19.3. I'm a beast. Alright, next one, number 10. Find the measure of the indicated angle to the nearest degree. So again, now I have an angle in two sides. I can use trig. When you got an angle in two sides, if you're looking for a missing piece, use trig. So this time I'm looking for the angle. Alright, but I'm still going to do the same thing. What they gave me here is opposite and hypotenuse. So remember, SOHCAHTOA helps you to determine which one to use. For opposite and hypotenuse, I'm going to use sine. Remember, what goes here is the angle. Now that's what I don't know, so that's what I'm calling x. And now I know both of these parts. It's opposite over hypotenuse. It's always set up that way. Whatever's first goes on top, what's second goes on bottom. But now I need to solve for x. And x is the angle. When you need to solve for the angle, the only way to undo this sign is to do the inverse. So I would do the inverse sine of both sides to get rid of sine, and x will equal inverse sine of 13 over 16. Okay? So the only time you should use this inverse sign, the -1 exponent, is when solving for the angle. So I'm going to go calculate now though, trig, and then they're right there. The inverses are on the bottom here. So inverse sine of 13 over 16. That angle is 54 degrees. Excuse me. So let's go look at 11. Looking for the angle. This time they gave me the adjacent and the hypotenuse. So I'm going to use cosine. I'm looking for the angle, so that's my x. Cosine is adjacent over hypotenuse, so that's the 30 over the 58. And then remember, if you're looking for the angle, that's when you're going to use the inverse. So x will equal inverse cosine of 30 over 58. Boom, 59 degrees. All right, moving on, number 12. When you get here, same type of idea, I got right triangles. So these units were all about right triangles. But here they want me to find the two missing sides. So I could use trig, but if it is a special right triangle, there's two special right triangles, then sometimes we have a method easier than trig. Okay? So the special rights are 45, 45, 90. So remember, all the angles have to add up to 180. So if I know this is 90 and that's 45, that has to be 45. And the other special right triangle is a 30, 60, 90. Okay? If you ever deal with these angle measures, then you can just use your special right formulas. For 45, 45, 90, you label the sides across from 45 x, and you label the hypotenuse x square roots of 2. Now for 30, 60, 90 triangles, you label across from 30x, across from 60, x square roots of 3, and across from 90, 2x. Okay? So, this gets a little confusing on some of these problems because they already label a side x, but don't let that confuse you. If it helps, maybe ignore those for a minute and then go label the way the formula says. So I'm going to go label this triangle 45, 45, 90. Across from the 45s, I'm going to call x. I'm going to call this side x. I'm going to call this side x. And then across from 90, I'm going to call x square roots of 2. Now, if you remember when I taught this, I told my kids there's one of two types of problems here. They either give you x or you have to solve for x. So they only gave me one side. That's this side. Well, that's the side that I labeled x. So that means they gave me x. X is 3 square roots of 2. So since this side is also labeled x, this side is also 3 square roots of 2. Now, I'm going to go look at my answer choices. Remember, I scratched it out, but that was y. So y should be the same. 3 square roots of 2. So please do not choose B and C. How easy to get it down to 50-50. Okay, so now here comes the only hard part. This side. This side is labeled x square roots of 2. But you know x. They gave you x. So plug it in. 3 square roots of 2 times square root of 2. You can multiply inside with inside. So that's 3 square roots of 4. Well, shoot, square root of 4 is 2. So 3 times 2 is 6. So I would be choosing B. Okay, let's go look at 13. Again, I'm going to go label. I talked about the labels over here. This is a 30, 60, 90. Across from 30, I'm going to label it X. Well, look, again, like I said, hey, that's the side they gave me, so they gave me X. This is easy. Across from 60, though, I'm going to label X square roots of 3. And across from 90, I'm going to label 2X. So, if they give you the side that's labeled X, all you have to go do is plug it in to the other two sides. This one's going to be the easy one. If X is 5, 2 times 5 is 10. So this side's 10. Oh, wow. If I can just do that, I got the answer. Now, the other side is just as easy. Again, X is 5. Okay, let me put a 5 here. Wow, 5 square roots of 3. Okay? Easy peasy. On to the next. Number 14. Name the most specific name for each figure. Okay, on 14, you got 4 right angles. All the sides are the same. Pretty much everybody knows that's a square. Alright, on 15, remember all 4-sided figures are called a quadrilateral. All these other ones have specific properties. So if you don't have anything labeled, you have no way to tell that it's one of these. So the most basic one is a quadrilateral. So on 15, since nothing's labeled, the only thing I can call is a quadrilateral. I can't assume anything. It may look like something, but if it's not labeled, I can't do it. Okay? So when I go look at 16, 16 is a quadrilateral, but I can get more specific this time. These two sides are parallel. That's what those arrows mean. And you just got to remember the property. There's only one that has only one side, pair of parallel sides, and that's a trapezoid. A kite has no parallel sides. Alright, now on 17, what's different about 17 and 16? 17 has one pair of parallel sides. So it is a trapezoid. It is a quadrilateral. But the most specific name, since these two sides are the same, if the non-parallel sides are the same, and we call it an isosceles trapezoid. So a little more specific. Alright, so yeah, it is one of these. It is a quadrilateral, but most specifically, it meets the requirements for isosceles trapezoid. Okay. 18. Find the area of each. You're going to be given a formula chart. So first, you just got to be able to know what shape it is. So we're trying to find the area of this shape right here. It's these solid lines. All right, it's got two pairs of parallel sides, so it's a parallelogram. And you go look at your formula chart, you'll see area of parallelogram is base times height. So here, they gave me the length of the base is 10, and they gave me the height. And the height is 3. So I just multiply 30 miles squared. On 19 is a rectangle because it's a parallelogram, but I know the angles are 90 degrees. Well, a rectangle and a parallelogram, same formula. So my area is base times height. My base is 3 and my height is 9. 27 centimeters squared. Alright, so looking at 20. 20 is a square because it's got right angles and all the sides are the same. Well, a square is the same formula. You just multiply the sides, base times height, or side squared, because it's 3 times 3, which is 3 squared, which is 9. Okay, these should be the gimmies. You got to get these right on the test. Now let's look at 21 though. 21 might get you, but we just talked about this shape. It's got one pair of parallel sides, so this is a trapezoid. Alright, it's got a different formula, so be sure you use the right formula. For a trapezoid, the formula is 1/2 times base 1 plus base 2 times height. Again, you have a formula chart. We're not asking you to memorize this, so you just got to make sure you know the shape so that you're using the right formula. Okay? Then you got to know how to utilize the formula. So it's 1/2 times, and a trapezoid, the two bases are these parallel sides. Well, they gave them to me. 1.5 plus 5.1. So I'll add those up, multiply by 1/2, and then multiply by the height, which is 2 meters. Okay? And I just go type it in like that. Especially if you're worried about making a mistake. Just type it in just like that. Be sure you put a plus. Boom. 6.6. What an easy final. What an easy final. Alright, let's go look at 22. 22 even tells you it's a regular polygon. So you're going to look on your formula chart for a regular polygon, and you're going to use the formula. The formula is 1/2 times apothem times perimeter. Okay? So you just got to remember this little line right here is called the apothem. It's from the center to the middle of this side. Well, it's given to you. So that's your A here, 11. And then you got to remember the perimeter is all the sides, the total distance around. Well, a regular polygon, all the sides are the same. So I know they're all 10.6, and there's 1, 2, 3, 4, 5, 6, 7 of them. So my perimeter is going to be 10.6 times 7. So I could get that total distance around. So don't forget to multiply by the number of sides. Now I go type it in. .408.1. Okay. Last problems. Been moving fast, but again, pause it, go back, rewatch it, slow it down. These are all volumes, so be sure on your formula chart you're using the formulas that say V equals. V stands for volume. Okay, so again, you got to know the shape so that you make sure you use the right formula. This shape is a cone. So for a cone, it's 1/3 times the area of the base times the height. Again, remember this stands for area of the base. So you have to calculate that. Okay? Or what we started doing in my class is, in the area of the base, we went ahead and wrote the formula within this formula. So for this base, the base is a circle. The formula for area of a circle is pi r squared. So I'd have to do 1/3 times pi r squared times the height. Okay, so it'd be 1/3 times pi times 4 squared times the height, which is 11. I'll go type that in. Remember, pi is down here at the bottom next to the h. (184.31) inches cubed. Okay, next up, this ball right here is called a sphere. A sphere. So I go to my formula chart, and it says volume is 4/3 pi r cubed. So literally the only thing I need is the radius. Wow, they gave it to me. The radius is from the center out to the outside. The radius is 9, so it'll be 4/3 times pi times 9 cubed. So more calculator practice here. 4/3 times pi times 9 cubed is 3053.63. Okay, 25. What shape is that? Well, that is a square pyramid. But most importantly, be sure you use pyramid. Pyramids come to a point. Prisms will be flat on top and bottom, the same shape. So a pyramid here, I go look at my formula. I notice it's the same as a cone. It's 1/3 times the area of the base times the height. Okay. Now here, the area of the base is a square, so I would have to do 8 times 8 to get that area, and then multiply by the height. So remember, make sure you remember this stands for area of the base. So you have to analyze what shape's the base. How do I calculate that area? And be sure you do that. Okay? So, last bit of finger work here as I punch these buttons. And I get 256. I go turn this in. It's 100. Gonna get 100 on the final. Woo! There you go. Go back, watch it again if you got to. Watch it the night before the exam. Study your problems, rework them. All those study tips. If kids study anymore, you should. Deuces.